Hello ladies, in this video we're just going to go through the questions from your indices and surds revision sheet. So there are 20 questions, just fast forward if you need to, but I'll try to keep it the video as short as possible. Okay, question 1. State the highest square factor of 75. So when you're simplifying surds, it's always a good idea to write down the square numbers. So the square numbers are 1 squared is 1, 2 squared is 4. I'm not going to write 1. 3 squared is 9. 4 squared is 16. 5 squared is 25. Oops, sorry. 6 squared is 36, and so on. Okay, and I'll just do the last ones, not the last one, but just to fit on the page 64. So they can keep going. So when it talks about the highest square factors, these are all your square factors and they'll keep going. So the highest square factor of 75 is 25. All right, question number 2. Express 11 root 5 as the square root of a positive integer. So if we've got 11 root 5, that basically means, all right, if we're going to put 11 into the square root sign, we're going to have 11 squared times 5. So 11 squared is 121. Okay, and then you would just need to do that multiplication. Sorry, I just got a bit distracted. So 121 times 5, if you want to do it like that. 1 times 5 is 5, 2 times 5 is 10, and 1 times 5 is 5. So we have 605. So it's the same as the square root of 605. All right, we'll just scroll so we've got a bit more room. So we'll get question 3 up. Okay, so simplify the surd. We've got 5 square root of 147 over 7. So what we've got to do first, so we're simplifying the square root of 147. So just coming back to these square numbers here, we'll say which of these square numbers go into 147. So it is 49. Sometimes it just requires you to go through every single question. Not every single question, every single number, every square number. Obviously, it wouldn't be an even number because we're working with an odd. So you'd just say, well, does 9, does 25, does 49, and so on. Okay, so 49 goes into 147. So I'm going to just get my mouse over. Good. So 147 can be written as 49 times 3. And also a little bit of a hint is that denominator 7. Okay, because when we simplify 49, and then we've got root 3, square root of 49 is 7. And oops, so that should have been over 7 as well. These 7s cancel out, so then we're just left with 5 root 3. All right, moving on to question 4. Let's just get some space. Come on. Use Pythagoras' theorem to find the unknown length of the triangle. So we've got our awesome triangle there. It's right angle clearly. Square root of 3 and 12. So Pythagoras' theorem, a squared plus b squared equals c squared. And that means c is equal to the square root of a squared plus b squared. Okay, so just substituting in the values of a and b. It doesn't matter which one you call a and b, but c will always be that longest side. Okay, so c is equal to, we can just put 12 squared, and then b is root 3. I like to put that in brackets. And square root sign, 12 squared is 144. And then root 3 squared, the squared and the square root sign cancel each other out. So we're left with the square root of 147. We do have to put it in its simplified form, and we did do the square root of 147 before, which was pretty good. So we know that is 7 root 3. Okay, we did the working out here. Remember, the 49 times 3 becomes 7. Sorry, square root of 49 times the root 3 becomes 7 root 3. So that's where the 7 root 3 comes from. All right, question 5. I think I've run out of room, so let me just quickly add a page. Okay, so we're using Pythagoras again. We've got 5 and 10. Okay, so your unknown side is the square root of 5 squared plus 10 squared. So that's 25 plus 100. So that's 125. And we need to simplify that. So the highest square number that goes into 125 is 25. And 25 goes into 125 5 times. So the square root of 125 is 5 root 5. If you're having trouble simplifying your surds, I strongly encourage you to go back and have a look at the video on simplifying surds and get a little bit more practice. So you never leave your surd unsimplified. So just like you would a fraction, so make sure you simplify your surds. Okay, question 6, we've got 5 root 125 plus 4 root 5 plus 2 root 125. Now we did take this, we did do root 125 in the previous question, so I know that's going to be 5 times 5 root 5. I'm going to cheat there. This one we don't simplify, and then this one here is 2 times 5 root 5. Now, just multiply the, oops, that's not 10. Just give me a second to pop that out. Yep, you go away too, please. 5 times 5 is 25. And then we have 4 root 5. And then 2 times 5 is 10. And you can only add like surds. So these are all like surds because they're all got the same base. So the square root of 5. So we're just going to add the number in front. So 25 plus 4 is 29. Plus 10 is 39. So all up, we've got 39 lots of root 5. Okay, let's move on to the next question. The perimeter of a rectangle is, okay, so let me just write that down. Perimeter is 28 root 11. Its width is 3 root 44. Find the length. So remember, the perimeter of a rectangle is 2 times width plus 2 times length. So basically we substitute in what we know. So the perimeter is 28 root 11. Your width, so we've got 2 lots of that. I'm going to run out of room here, which is a pain in the bum. Okay, so 28 root 11. Why did I write W? Okay, I wasn't concentrating. That should have been a 3. I think that notification coming out was distracting me. Sorry. Plus 2L. Okay, before I start, and make sure you see that's an L, before I start solving for L, I'm just going to actually, I'm just thinking on my feet here, we could, actually I'm going to do it. I'm going to simplify first. You could have divided everything by 2. That's what I was thinking in my head. But what I might do is just simplify this root 44. So the highest square number that goes into 44 is 4. So 44 becomes 4 times 11. And then we've got 28 root 11, which is nice because I can see I'm going to have a root 11 here. This is going to be square root of 4, which is 2. So that becomes 12. And then we've got 2L. And now I'm going to start running out of room. So let's just see if I can. Actually, I might just rub that out. Bye. Okay. Oh, and you pop up. Of course you do. Okay. So 28 root 11. Am I writing the same thing again? I am writing the same thing. I was thinking I needed to simplify, but it was already simplified. Okay, so I can put the L on one side and this on the other side, but I'm going to divide everything by 2. Okay, so the reason for that is just so I've got L by itself. So at the moment it's 2 times L. And remember, whatever you do to one term, you need to do to every term. So because I divided that by 2, I need to divide this by 2 and this by 2. So that becomes 14 root 11. This becomes 6 root 11. And that just becomes L. So L, now you got to stick with me here because I'm running out of room. We're going to take away 6 root 11 from both sides. And that goes. So 14 minus 6 is 8. And then we're just left with root 11. Okay, let me grab a new page. Keep working. Maybe I'll do a few new pages. I think I'd be more organized and have a lot of blank pages. Oh, there we go. Okay, let's move on. Question 9. So we've got 2 root 5 times root 5. Now, when we do this, you can see everything is under the 1 square root sign. So before I do that, I'm going to write this 2 as a square root of 4. Okay, so that's 2 is a square root of 4. Then we've got root 5, and there is a multiplication sign there. We just don't write it. And then there's a multiplication sign here. So we're effectively can put everything that is under a square root sign under the same square root sign. That only can happen when you're multiplying. So we've got under here 4 times 5 times 5. So 5 times 5 is 25, and 4 times 25 is 100. So I'm wondering why they're making that the square root, because that is effectively 10. But the answer would be the square root of 100. Bit of a silly question, but we're all learning. So I think the important thing there is doing this. But leaving your answers the square root of 100, it should be 10. Okay, let's scroll. Rationalize the following. So what it means by rationalize the following, because we never keep, no, what is that? It's on the eraser. Okay. So what it means by rationalizing is we don't keep a surd on the denominator. So to get rid of it, we're multiplying root 3 over root 3. Now, first of all, why we do that? We're not really changing the value of this because any number divided by that same number, so if we had 2 divided by 2, 10 divided by 10, root 3 divided by root 3, it's still going to be 1. So we're effectively only multiplying it by 1. So it's not changing at all. But what we're doing is now in our denominator, root 3 times root 3. Remember, like I did before, you can put those 3's under the same square root sign. So it becomes root 9, and square root of 9 is 3. So what we have on the denominator, the square root signs cancel out, and we're just left with 3. And then on the numerator, we've got 7 times 3, which is 21. Okay, and you can't do 21 divided by 3 because it's not 21 divided by 3. It's the square root of 21 divided by 3. And remember, the square root of 21 is somewhere between 4 and 5. Okay, so it's not 21. It's the square root of 21. Okay, let's move on. Question 11. What is the value of m? So here we're getting into some indices now. So we've got g to the power of 4 times m equals g to the power of 12. Now, using your index laws, we can multiply these two, so it becomes 4m. And when your bases are the same, and you're solving for your powers, that means 4m is equal to 12. Then divide both sides by 4. So m is equal to 3. All right, the next one, I think I can just fit in here because it's not going to be a long one. 12 x to the power of 0. Here we've got the 0 law or whatever it's called, I can't remember. But anything to the power of 0 is just 1. Okay, so you need to remember that. Anything to the power of 0 is 1. So this is effectively 12 times 1, which is 12. Okay, so don't let those sorts of questions slip you up. Anything to the power of 0 is 12. All right, question 13. So we've got 2q to the power of 8. That looks like a 3. Now, I always prefer to write my divisions like this as a fraction. So then we've got 2q8 to the power of 2. So on my numerator, I've got 2q. Now, 2 and q8 to the power of 8 are all both to the power of 3. So don't forget that. I nearly did forget that. So 2 to the power of 3. And q is 8 times 3, which is 24. And then on the bottom, we have 2 to the power of 2. And then q8 times 2 is 16. Now, using your index laws, you don't have to do 2 to the power of 3 is 8 and then 2 to the power of 2 is 4. These powers, so we're dividing here. So that means, so 2 to the power of 3 divided by 2 to the power of 2. When you're dividing, your powers are subtracted from each other. So 3 minus 2 just gives you 1. So that disappears and that becomes the power of 1. So we're just left with 2 on the numerator. And when you think about it, we were effectively doing 8 over 4, which is 2. And then our q, we've got q to the power of 24 minus 16, which is 8. Okay, so remember when you're dividing, your powers are subtracted. All right, question 16, enter the missing coefficient. So again, I'm going to just scroll for a bit. Thank you. I'm just going to rewrite it as a fraction. So we've got 6y to the power of 5. And then we've got 8y to the negative 3. So do your coefficients first. So 16 divided by 8 is 2. And then we've got y to the power of 5. Because we're dividing, we subtract our powers, minus negative 3. And there's nothing on the numerator because that 8 was cancelled, not cancelled, but we divided it into the 16. And then this negative 3, it will become 5 minus negative 3, which is positive 8. So your answer there is 2y to the power of positive 8. All right, we're getting there. So we've got the fourth root of 81. So the fourth root just means what number, when multiplied by itself 4 times, gives you 81. So most of the simpler ones you should know. So this is basically going to be the fourth root of 81, and we also have to do the fourth root of a to the power of 10. So if you separate them, sometimes it's easier to see. The fourth root of 81, I think, is 3. Let me just check. So 3 times 3 is 9. 9 times 3 is 27. And then 27 times 3 gives me 81. Good. So that's going to be 3. Another way of writing the fourth root is, I'll just write that in a sec. So the fourth root is to the power of a quarter. So that's going to be 3a to the power of 10 over 4. And this is where it's important that you simplify, because even though I'll be checking your answer, you should write it in its simplest form. So 10 over 4 is 5 over 2. Okay, so make sure you just simplify that. but I will make sure that that one's a bit of a pain. If you did write 10/4, technically it's not wrong, but you should write your answer in simplest form. Okay, let's add another page in. Okay, maybe we'll make do with just one more page. Okay, here we have the fourth root again. On my eyesight, I can hardly see that little a in the middle. The fourth root, what have we got? 16a to the power of 20 over 625. Okay, again, you can separate the numerator and the denominator. So we've got the fourth root of 16a 20 over the fourth root of 625. Okay, so this is a tricky one. So we've got what number when multiplied by itself 4 times gives you 16, so that's 2. And then we have a to the power of 20, and that's to the power of a quarter. Okay, so we'll do that part separately. And then what number multiplied by itself 4 times, and that's 25. Okay, so 25, oops, no, it's not 25. It's 5. Let me just rub out that 2. So 5 times 5 is 25. 25 times 5 is 125, and then 125 times 5 is 625. Okay. So I've got that 2. And then when we have a power to a power, we multiply. So 20 times a quarter is 20 over 4. We can simplify that in a second. So we're left with 2a. This becomes, 5. That was an easy one. And over 5. Okay. All right, so moving on. Sorry, I just was thinking. Question 17, simplify. So what have we got? 125, a to the power of 6, b to the power of 12. Oh, I think that is a third to the power of a third. Yep. Okay, so again, what number when multiplied by itself 3 times gives you 125? And that's 5. We do a to the power of 6 times a third, so it becomes 6 over 3, and then b to the power of 12 times 1/3, so it becomes 12 over 3. So we've got 5a squared, b to the power of 4. Okay, question 18, I might just put over on this side. So 7k minus 5 equals 1. Oh, this is it's a good question, but I think it would stump a lot of people. Okay, so we remember when we're solving powers, we have to have the same base. So I do have to write 7 here. And you've got to say, well, 7 to the power of what gives me 1? And remember, as I said before, any number to the power of 0 gives you 1. So now that we have the same bases, I can let k minus 5 equal 0. So that means k is equal to 5. Okay, so a tricky one, just remembering that 0 power. All right, 2 more questions. Just going to block that off. So we have 9 to the power of y equals 27. So we have to write both of them to the same base. So 9 I can write as 3 squared, but I need to do that to the power of y. And then 27 I can write as 3 cubed. So just multiplying those powers, so 3 to the power of 2y, 3 to the power of 3. So now we have the same base. So now I just let my powers equal each other. So 2y equals 3. Divide both sides by 2, so y is equal to 3 on 2. All right, last question. Do we have space? Oh gosh, make a new page. Okay, so question 20. Y to the power of 1 sorry, let me start again. Y equals 1 to the power of x would graph to form, oh, okay. All right, this is a bit of a tricky question. I couldn't even read it properly. I thought it says, yeah, anyway. So let's think about different values of x. So let's even just draw up a table. And you don't have to do this to solve this question, but it's just an understanding of what is happening here. So if we had x equals 0, we've got 1 to the power of 0, which is 1. If we let x equal 1, we've got 1 to the power of 1, which is 1. Then we've got x equals 2. Y to the power of 2 is 1. So basically what we've got, if we're to draw the graph, we've got x equals 0 here, then 1, then 2. So 1, 2. And we've got a point here, 1. Another point here, another point here. So if I was to sketch that, and if I kept going, you can kind of see what's happening. 1 to the power of 3 is 1. So your answer is it's going to be a horizontal line. All right, so some tricky questions there, girls. It was, I purposely chose the harder ones. Don't always know whether that's a wise thing to do because some people get put off, but there's a lot of skills there that you do need to know. So make sure you do the revision questions in your textbook, and I'll also send through some, if I haven't done so already, some practice tests and some worksheets. All right, bye.